All right. Thank you all for joining this webcast. In this webcast, we will be looking at SQL Server 2012 AlwaysOn availability groups and how we can combine AlwaysOn with LogShipping. My name is Chandra Mohan. I'm a SQL Server PFE at Microsoft Dubai. Right. So we'll start the session looking at the table of contents. So to begin with, we'll be looking at common high availability solutions and limitations, if any. We'll also then review the considerations for AlwaysOn and AlwaysOn availability groups. We'll then quickly look over some known issues that you should be aware of. We'll then focus on how to implement LogShipping on a database that is actually already part of a SQL Server availability group. Lastly, we'll look at a single slide looking at the improvements of SQL Server 2014 new features in relation to AlwaysOn. Right. Common high availability solutions. Talking of common high availability solutions, in the past, when the requirement was to have automatic failover of SQL Server service, we would then choose SQL Server failover clustering, whereby all the databases in that particular instance fails over. With database mirroring, we then get redundant copies of the same database so that we didn't have a single point of failure. With database mirroring, you have application failover that's accomplished through use of a failover partner connection string parameter. So you get automatic failover between principal and mirror. Right. So you also could combine failover clustering and database mirroring to achieve local service level failover and remote database level failover along with data redundancy. Also, we could combine mirroring and LogShipping to achieve automatic database failover with mirroring and achieve data redundancy as well. Then we could implement LogShipping alongside with mirroring to provide a warm standby server in another environment. We also had peer-to-peer transactional replication that provided us with a scale-out high availability solution by maintaining copies of our data across multiple SQL Server instances. This was, as we know, built on a foundation of transactional replication. Peer-to-peer replication propagates transactionally consistent data in near real time. This enables applications to quickly scale out to distribute reads from clients across multiple nodes. Because data is maintained across nodes and that too in near real time, P2P replication provided us with data redundancy, which increased the availability of data in those nodes where replication was configured. So these were some common high availability solutions that we are used to in SQL 2008. Now we look at a few limitations that we have had in the past. The first thing is that solutions are a bit disconnected. They're not a single wizard that can help us implement most of these solutions. And each of them also have a little bit difference in terms of what kind of hardware and software requirements were needed. With SQL's failover clustering, for example, SAN becomes a single point of failure. So if we lose the SAN disk, then we lose the entire database, and your cluster, even though it can survive, is not going to be viable. Mirroring allows one mirror, and you got automatic failover of a single database only. So if you wanted to have multiple databases to fail over at the exact same time, then we needed to do some custom coding and custom implementation. But again, there's not guaranteed that it's going to work at the same time when you require it. LogShipping also, likewise with mirroring, it depends on the backup and restore times. We may end up losing some data, and we also don't get automatic failover. Other point is that most of the times we see in customer implementations that the passive nodes are not used for productive purposes. So it's either a passive SQL Server node which is participating in a cluster, or a mirror, or a LogShipping partner. Mostly are not doing much of a work. So offloading could be done in terms of mirroring or in terms of log shipping also. But then it was not very straightforward. We needed to create snapshots and maintain them properly. And in log shipping, we had to disconnect users while the data was getting restored and so on. Like the above, even with P2P, there is no automatic detection of failures or automatic failover. So manual intervention was required. But in SQL Server 2012, the answer to this is a bit more easier approach by implementing AlwaysOn groups. We get redundant copies of the database, up to 4 that exist inside the availability groups, and we could use synchronous or asynchronous replication with automatic failover support. Now, talking about failover support, we also get multiple databases failover, which was not available. So all databases within a group are going to failover from one node to another. If you also implemented the availability group listener, then the application uses the virtual server name that exists within the failover cluster resource. So the availability group fails from one node to another, and that way application also gets instant redirection to that group on which to that instance on which the group is running on. So as you could see, some of these limitations are addressed with SQL 2012. We'll then start looking at what are the considerations we should have when we implement the AlwaysOn. The first thing we want to look at is the quorum model. In general, having a quorum, we know that avoids two subset of members that are attempting to service a request or writing to the same disk. This situation could cause corruption. In order to achieve quorum, we know that each node provides a single vote towards the membership. A physical disk or a file share may also be used as a quorum, but that is only if required, depending upon the quorum model that we choose. The default quorum model that is implemented when the cluster is configured depends on the number of nodes, whether they are even or not, odd numbers. If the number of nodes are even, and if shared storage is available, the default model we pick up is node and disk majority. Likewise, if the number of nodes are odd, the default model is node majority. There are other two models in terms of quorum selection, typically file share resources, and lastly node majority, in which case these are not going to be implemented out of the box. They have to be configured separately. Node and disk majority is the default model when the number of nodes participating are even, and likewise node majority is the default when the number of nodes participating are odd numbers. As I mentioned, node and file share majority, it uses the file share resource, which most likely is going to be located outside of the cluster to serve additional vote when determining quorum in a cluster. This is typically used in what we call as geo clusters. So the quorum models have to be taken into considerations while setting up AlwaysOn to ensure proper configuration of the quorum is done at the operating system level. One more thing I would like to add here is that in order to simplify the quorum configuration and to make sure it is up most of the times, we can also use the node weight property to adjust the setting on each node that is going to vote towards a quorum. Normally, we recommend to exclude the secondary sites that probably are in the disaster recovery site from the voting process. But again, each time you do a failover or something like that, we need to reassess the vote assignments after the failover. So these are some things that you need to consider when you're setting up the quorum model. Now, coming to backups, we had a challenge in SQL mirroring that in the previous versions that we couldn't take backups from the secondary nodes or the mirror partners, but that has been fixed with SQL 2012, that the secondary replicas overcome that shortcoming of database mirroring, because you can use a secondary copy of the database to perform backups. That actually frees up the resources on the primary database. Backups can be completed from any replica. you can use the secondary replica to perform copy-only full database backups, or you could use file or file group backup, and also transaction log backup. Copy-only backup is a backup that is independent of the sequence of the routinely scheduled backups, so it won't affect the normal restore process of the database. Single chain of transaction log backup is maintained irrespective of where the transaction log backup occurs. So this is done by tracking the log sequence numbers across all the replicas. The sequence ensures that even though we take transaction log backups from different nodes, we can still use them in case if there is a disaster. One note about differential is that it's not supported on the replicas, so that's something we need to remember. Moreover, you can also configure the availability group to specify where the backups can be performed. The other point we need to also remember is that when we create maintenance plans, or when we create when we enable log shipping, then depending upon how we configure the availability group for backup purposes, these maintenance plans and log shipping automatically uses those backup preferences that we have already set. In order for the backup to run, the secondary replica must be in synchronized or in synchronizing state. The secondary replica also should be able to communicate with the primary in order to run the backup from the secondary replicas. So these are some aspects we need to remember in terms of backups. I'm moving on to the second slide for considerations that we need to remember. Here we're going to talk about the application intent and stuff. So with AlwaysOn, we also have what is called as read-only routing. What it refers to is the ability for SQL Server to route incoming connections to a availability group listener to a secondary replica that is configured for read-only workloads. An incoming connection referencing availability group listener can then automatically be routed to one of the read-only replica if some conditions are set to true. Right. So what are the conditions? The first thing is availability group listener should be configured on the client to connect to the virtual network name or the VNN as we call it for short for that particular availability group. And in the connection string, the application intent should be set to read only, as you would see in the slide. For example, the connection string example we have here connects to server A on database adventure works with the application intent set to read only. So that's something that needs to be set. Read only routing may take sometimes a bit more longer to connect. So that's something which you need to remember, because read only routing first connects to the primary and then looks at the best available readable secondary. So that may take a bit longer to connect. Because of that, you may want to consider increasing your login timeout for such connections. So another option for read-only users is that if you don't have the listener connected, you could potentially connect directly to the secondary instance also. That's another option. So as you see in the example, to configure, for example, read-only routing for the secondary role, in the modify replica clause, you need to specify the secondary role option. Likewise, to configure read-only role in the primary, you have to say modify replica with clause. You have to specify the primary role option. So here we have used computer 1 and computer 2 in order to identify the instances. So that's something which we can do in order to connect read-only users to or rather basically offload read-only connections to the second node or the mirror node, for example. Right. Now, when we talk about some considerations of availability groups, we then talk about things that you can do or you cannot do and things like that. For example, the first thing you cannot do is that system databases cannot participate in AlwaysOn groups. Basically, the other point you need to remember is that they all fail as a group. So all databases within one particular AlwaysOn group will fail over or fail back together. If asynchronous mechanism is used for AlwaysOn, there could be a possibility of data loss, so that's something you need to remember. Of course, other things that you need to remember is that we need a full recovery model. Backups of transaction logs are also important, and any objects outside of the AlwaysOn, for example, any jobs and things like that that's created outside this group needs to be manually created on the replication partners as well. Okay. Now here is a quick example of AlwaysOn availability group. For example, here we have replica 1, which is the primary replica, and then we have replica 2, 3, and 4, which are going to be the secondary replicas. And you would notice that replica 1 replicates to 2 and 3 using synchronous data movement, and we use the asynchronous data movement to replicate to replica number 4. Now, apart from that, we can also take backups and run reports on the replicas other than running these things from the primary replica. So this is probably an often used slide or an often used example to show how AlwaysOn groups work in 2012. Moving on, quick note on the multi-subnet failover cluster. So as you would see here, we have 2 nodes in one subnet and 2 nodes in another subnet, and obviously they'll be having different IP addresses on which they're going to be listening on, and the network name is going to be the same common SQL class. For instance, here IP address on the first subnet is going to be 10.168.0.10, and if there is a failover on that particular subnet, or rather if the nodes there fail or can't be accessed, then we fail over to the second subnet, which listens on a different IP scheme. So the one thing that we wanted to mention here was that we either listen on one IP address or another IP address. So there is a OR dependency, not a AND dependency. So that's a quick note on the on the failover clustering while you implement that on a geo cluster mechanism. Right. Some common issues that we normally see when we create listeners, for instance, is that after the availability group is created, the availability group listener is then created. So it is nothing but a computer object that is created in Active Directory. Sometimes what happens is that the listener name may not get created and you may get some error messages. So one of the reasons is that we have probably lack of permissions to create the computer object for the Windows failover cluster computer object, which is the cluster name object itself. So if the cluster name doesn't have permissions to create computer objects, then we normally get accesses denied, error messages, and similar things. So to fix that issue, we probably need to just go into the Active Directory users and computers, go into the organizational unit, right-click the OU, and then give permissions as it's mentioned in the slide deck here. So after that, when we try to bring up the listener, that should then come online, and we should be able to create that object on the Active Directory. And that should resolve the problem. A second thing that we probably come across is that multi-site cluster. So in this case, what we are looking at is we're looking at different IP addresses. So if the environment is something similar to a multi-site cluster with 2 IP addresses, then we have those IP addresses that will be registered with the DNS server. So only one IP address can be online at any given time, like we saw in the previous slide. So the primary site, primary node site is checked internally, and if the IP address is present on the primary, then it is set as online. So when a client connects using a listener name, both the IP address are queried in parallel, and the client is connected to the IP address that returns the reply. So in order to query to the IP address in parallel, we need this property, multi-subnet failover, that should be set to true in the connection string. This is, for example, this is supported by, let's say, SQL CMD, which supports the -M switch for multi-subnet failover. So most of the applications definitely, when they connect to this failover subnet, when they connect to this availability group, they should be using this particular property. If the connection string cannot be changed within the application for some reason, then we have another workaround, is that the register all provider IP for that listener name should be set to 0. If one of these steps is not done, the IP addresses are queried one by one in a serial way, and the first IP address, if it is online, then connection timeout may happen. There are a couple of KB articles that talks about these issues. So this is one another issue that we need to be aware of, especially if you're using a multi-site cluster. This parameter is typically supported in the newer versions of the SQL client, things like .NET Framework 4.0, and it is actually also backported to .NET Framework 3.5 as well. So that should not be a problem. Right. Now, yeah, this is what I wanted to mention about on this slide. Now we move on to the log shipping. Let's first do a quick recap about how log shipping works, and then let's try and see how we can implement this with AlwaysOn. So we all know that we can use log shipping to create copies of a source data on multiple standby servers. And to do this, typically we do a backup of the transaction log on the primary and apply this on the standby servers. So this goes through, as you see, in a 3-step process. So at the first step, transaction log backup is taken on the primary server. This particular part, or the backup of the transaction log, happens on the primary server, or the job runs on the primary server. Hence, the job is obviously created on the primary server itself. The next step is the backup that is taken will be copied from the primary server to the secondary server. And this particular step of copying runs on the secondary servers only. Hence, the job for that is also created on the secondary server. The last step is that the copied backup to the secondary will then need to be restored. The restore of this transaction log backup happens, of course, on the secondary server, and because of that, this restore job is also created on the secondary server only. So one more thing we can set while restoring this is that how the database is going to be accessible or not on the secondary instance. So the secondary instance can allow connections to the database, or by being in standby mode, which allows read-only access. But then there is one drawback with using this particular option, and the drawback is no client connections can be present while applying the transaction logs from the primary server. And this process must disconnect clients automatically, or else the transaction logs can accumulate, and the secondary server again may not be refreshed with the latest logs. Apart from the above, because the entire transaction log is also going to be copied across the network, this may result in some additional network bandwidth and latency, which you should be keeping in view. Lastly, as we discussed with other failover mechanisms, log shipping also does not allow automatic failover. So this is something which needs to be done manually after configuring log shipping, if in case you need to do a failover. Okay. Moving on. So here is a diagrammatic representation of how data is going to be moved, or how log shipping works. So as you see, the green cone or the green box represents the primary database where all the backups are performed. So transaction log backups are performed, and then there are 3 copy arrow marks you see there. This copy arrow mark is now going to copy the transaction log backups from the primary to the secondary. And we said that the copy job runs on each of these secondaries. Lastly, we then restore the copied backup on the yellow boxes, which indicates the secondary servers. Now, the dotted arrow marks represent that you can have a fourth machine outside of this LogShipping configuration that acts as what we call as the monitor server. Now, this monitor server gets pumped with data from all four servers saying that, okay, I have done the copying, the backup bit. That's what the primary database is going to say. And the secondary databases or the secondary servers may come back with status messages saying that, well, I have done the copying bit to my machine and I have done the restoring bit, or basically have or have not. So this is the information that's going to be in the monitor database, which will then raise alerts depending upon what kind of messages are coming in. So that's a quick diagrammatic representation of how LogShipping works. Now we will actually look at the steps that we need to do in order to configure LogShipping on a SQL Server database that is already part of a AlwaysOn group. So first thing is, on the primary server, on the AlwaysOn Primary server, we need to set up the LogShipping. So in order to do that, first thing what we do is that we go to the properties of the database, and in the left hand side, of course, we select the transaction LogShipping tab, and then we enable the check mark that says enable this as the primary database in the LogShipping configuration. Once we have done that, we need to click on the backup settings, and on the backup settings window, we need to specify, for example, where exactly the backup is going to go, right? Now, apart from that, okay, in this case, as you would see, you probably don't want to put the backups on the local machine as that of the AlwaysOn Primary, because if that server goes down, then we may lose access to that backup location. So we normally recommend that this backup share should be on a different machine other than the other than the AlwaysOn Primary or AlwaysOn Secondary. So that's the first thing that we want to do. Of course, you would then set up the schedule. How often do you want the backup to happen? Maybe 1 minute, maybe 1 hour, etc., etc. Right. So once that is done, we then can script out the configuration. Now, why do we need this? Is that we are going to set up LogShipping on the AlwaysOn Primary, and then we have to go and run the same setup on the AlwaysOn Secondary as well. So in order to make it easy on us, we can then get the script out the information from the primary so that we can run it on the secondary. So as another step, we would typically script it out. Of course, you can do that separately also, but this is an easier approach. I'll tell you why later. Now, once we have scripted out, we can then click on the add button that you see on the first snapshot to go and add the secondary LogShipping secondary servers. Now I'm going to click on next, assuming that we have clicked on the add button. Now, when we did the add button, we then have we're going to add the secondary servers. So in this slide, we will see how to do that bit. So after clicking on the add button, you will see the following dialog. Then we click on that server, or basically we connect to that server, and then start the click on the appropriate option to initiate the secondary servers. And for example, that's the slide that you would be looking at, or the dialog box that you would be looking at. In this case, I have selected yes, or basically the first option, so that I take the full backup from the production server and then restore it on the secondary server. We then click on the copy files tab. So when you click on the copy files tab, we basically are going to say that, okay, we have taken a backup on the primary. Where are we going to copy this? On the LogShipping secondary server. So in my case, I have provided a local folder on the LogShipping secondary, which I have mentioned as C LogShip. So it could be any other different folder on any of those LogShip secondary servers. So once that is done, of course, you have to also set a schedule saying that when often or how often do you want the copy to happen. So that's once that is done, you can click on the restore transaction log. So once you click on that tab, you then select the database state. Do you want that to be accessible or not? So that's something which we control from here. So you can use the no recovery model, which means the database will not be accessible, or you can use the standby mode, whereby you can then use this database for read-only access. And that's when you probably can also select the disconnect users in the database when restoring backups, because this is if you don't do that, then we can't restore the backups. So these are the options that you need to do in order to configure LogShipping. So once you have done this, you can click twice, OK twice. That will get you back to finish the process. So once this is done, so right now what we have done is that we have, let's clicking on OK twice to finish. So what we have done is we have set up LogShipping on the AlwaysOn Primary. And we have also set up the copy job and the restore job on the LogShipping Secondary. So that then leaves us only to create the backup job on the AlwaysOn Secondary server. So at this stage, we have two options to do so. How to set up the LogShipping backup job on the AlwaysOn Secondary. We can do this in two means. The first option is to use the script that we generated earlier on. And that's the script that you're seeing in the slide right now. This script can help us set up AlwaysOn Secondary to enable the database for LogShipping, and then create the backup job on the AlwaysOn Secondary server. Or the other step, or the other option that you can choose is that failover the AlwaysOn group to the AlwaysOn Secondary, make that as the primary now, and then set up the backup job. Now, the advantage with the first option or with the first approach is that if you have to just run this particular script on the AlwaysOn Secondary, we then don't have to do a failover. So that is why I prefer the first option, as a failover can be avoided. So once we have done that, these are the only steps that we need to do on the AlwaysOn Secondary. Once we have done that, we just need to make sure that the LogShipping is working. Data inserted from the AlwaysOn Primary is making its way into the LogShipping Secondary based on the schedules that you have set. And of course, when you do a failover and failback, you can also make sure that the jobs are working properly and so on. Right. So I'm going on to the second onto the next slide. Now, once we have finished all that, typically you will be looking at these kind of jobs on the primary, secondary, and on the LogShipping Secondary as well. So as you would see, we have the backup job on the primary, on both the AlwaysOn Primary and AlwaysOn Secondary, and then we have the restore or the copy and restore jobs on the secondary LogShip servers. And apart from that, you have a common alert jobs on each of the servers that is participating in the LogShipping. So if you have made sure that these jobs are existing and are running properly, then I think you're all set to run LogShipping along with AlwaysOn. Now, if you remember earlier, I mentioned that you can set the backup preferences and stuff like that while you set up AlwaysOn. Now, LogShipping also recognizes these backup preferences, and the backups or the transaction log backups will run based on the preferences that you have set. So we don't have to really worry about which server is going to run the backup or which server is not going to run. So that will be automatically taken care of because LogShipping understands those backup preferences. So that brings us to the last slide actually. So here we're going to talk about some new features or new changes that SQL 2014 is going to bring along specifically to AlwaysOn. Although I haven't seen any changes on the LogShipping side, there are quite a few of them that's worth discussing. that's what's being called out in the stage in terms of AlwaysOn. So the first thing is, for example, when you're disconnected from the primary replica, because if there was a quorum loss or something like that, the readable replicas still remain available for read-only workloads. So that's the first thing that you probably want to be aware of on SQL 14. The second thing is we have increased the number of secondaries from 4 to 8. Earlier it was 4, now we made that to 8. And then there are some enhancements in terms of increasing the efficiency or to troubleshoot availability groups and things like that. So we have some new new system stored functions, or we have some more simplified error messages, additional explanatory warnings and things like that. Or also even the dashboard kind of emits more information when the data synchronization is happening and so on. So that's another enhancement. In terms of migrating, or in terms of talking about taking your databases into the cloud, there is quite a bit of improvement here as well, so that you can migrate your Windows Azure by using the Add Azure Replica wizard. That is, you can add AlwaysOn Secondary to be on the cloud as well. So this wizard basically creates the new replica for the availability group and so on, kind of an end-to-end process. So that's another new feature. Another feature is the cluster shared volumes. So in the earlier Windows 2008, when it was first introduced, SQL Server did not support cluster shared volumes. But now with Windows 2012 and SQL 2014, we will be supporting the cluster shared volume as cluster shared disks. So that's another improvement. There are a few more DMVs for better managing failover clusters. So that's another change. A couple of DMVs are probably going to be deprecated as well, but otherwise these are some major changes that you would be looking at when you install 2014. Right now it's in CTP2, so I encourage you to go and download and try it out. So that brings me to the question slide. In case if there is, I'm going to be around for another 15-20 minutes or so. So if there is any questions, feel free to bring them up. We can take them.